So like I said, these properties are going to be the reasons why we're allowed to do stuff using deductive reasoning. Deductive reasoning requires justification. And so what we're going to start with is solving equations. Solving relatively simple algebra equations. Some of them may be 5 or 6 steps. Some of them are just going to be 1 step. But learning how to then not just solve the equation, but justify it. Now, I tell you right up front, the goal here is not so much when we set up these equations to find the value of x or n or whatever the variable happens to be. I know you know how to find the value of x or the value of n because you've been through Algebra 1. So you know how to do that. The process we're concerned about here is the justification. Why do we do it? Now, most of these are fairly straightforward. Addition, subtraction, multiplication, division, property. That's how we justify doing something to both sides of an equation. But please note, because it is important, these require us to do both sides of an equation. All 4 of those do. If I'm just doing it on one side, it's not one of those properties. It has to be something that's done on both sides. Substitution property says if A equals B, A or B can be substituted in any equation. It's also used to combine like terms. So if I have a 3 plus 5 somewhere and I just say that equals 8, by simplifying it, by combining the like terms, that is substitution. It's a little different from what you've seen before, but that's what we're going to call it in geometry. That process of combining like terms. So after substitution, you might want to put in parentheses combine like terms. On one side. So if I'm combining like terms on one side, that's substitution. Distributive property, I think you're very familiar with. A times B plus C equals AB plus AC. We're distributing that A. You've done that a lot. The last 3, reflexive, symmetric, and transitive, seem almost silly at some point. But reflexive, we won't use a lot today. We will use a lot in the future. Reflexive property says everything is equivalent to itself. And while right now you may not see a point at which you'd ever need to state something like that, believe me, it's going to happen. Symmetric property, again, don't use it very much here, but it does allow us to switch things around to either side of an equal sign. If A equals B, then B equals A. I'll show you one example today where we're going to want to do that just for the sake of using it. It's usually not necessary, but we do have to justify everything, so that property exists. Transitive property is like syllogism. If A equals B and B equals C, then A equals C. Again, I think it's something you're pretty used to. And it's a nice little shortcut. Saves us lots of steps having transitive properties sometimes. So let's take a look at this. How do we use it in algebra? We're going to start with the very simplest possible equations, one-step equations. X plus 5 equals 10. Now, I think everybody looking at that problem immediately knows what the answer is, right? We can all handle that. That's not hard. The question is, though, how do we justify that? If you're showing your work, what are you going to do to both sides of that equation to solve it, Sammy?
Subtract 5.
You're going to subtract 5 from both sides, okay? We all know that. And we get our solution. But what tells me I'm allowed to subtract 5 from both sides of the equation? Why can I do that? Which of the properties that we just saw allows me to subtract 5 from both sides of the equation? How dare I do that without justifying it? Yes?
Subtraction property.
The subtraction property does. So that's what we're doing here. Is we don't just say, I'm subtracting 5 from both sides. Why? Why are you allowed to do that? What gives you that permission? Justify it. Why? Because the subtraction property tells me I can subtract whatever I want from both sides of an equation. And we get our solution. I mean, very, very simply, we get x equals 5. Now we have to be a little careful that we don't work too quickly on something so simple. Because I could very, very easily look at this plus and go, oh, addition property, because it was a plus 5 and now it's gone. Remember, we're always doing what we do if we are showing our work, justifying, and this is one of the reasons why we always say show your steps, justify everything. All right, let's look at another one step. 3x equals 15. How do we solve that? Go ahead. I'm sure everyone else in here knows. What are we? Well, hold on. You guys answer the last one. Go ahead. What are we going to do? Okay, so you're going to divide both sides by 3. What allows me to do that? Which property? The division property. It's pretty simple. Once you kind of get the hang of it, it's like, oh, that's all? Okay. All right, so how are we going to organize this? Because we don't want to just have to write paragraph after paragraph about this. We want to organize our information. And the way we are going to be organizing it, the way I expect you to be organizing it as well, is using this 2-column proof format, where we draw the horizontal and the vertical line to create 2 columns. This is a format we're going to be using all year, this 2-column proof idea. Because we're not just solving equations now, we're proving equations by justifying every step along the way. And one step at a time. We can only do things. This really forces you to slow down and just do one step at a time. Now, we start out with the equation that we are given. In this case, my equation is this. 2 times the sum x plus 3 minus 8 equals 5x. And my reason for my first step is given. Notice each step is numbered. I would expect that you're doing this as well, that you're numbering your steps. Step 1, step 2, step 3, step 4, step 5. Sometimes there'll be 5 steps, sometimes there'll be 2 steps, sometimes there'll be 7. It's all going to depend on the particular equation. And then I do something. I actually simplify something a little bit. So what did I do to get from step 1 to step 2? How did I get there? What changed? What you got? I distributed, didn't I? And we used distributive property. Oh, didn't mean to clone. I meant to delete. There we go. We used a distributive property, didn't we? What next? Okay, I went from 2x plus 6 minus 8 equals 5x. The right side did not change at all. It's still 5x. The left side, now it became a 2x minus 2. I combined like terms. Which of my properties did I say allows combining like terms? Check your notes. What do you? Excellent. Good job. Combining like terms is substitution property because I'm working just on one side. I didn't do it to both sides of the equation. I didn't add 8 to both sides or anything like that, did I? I just combined these terms on this side, the positive 6 and the negative 8, into the 2. That's combining like terms. That's substitution. Now it gets even easier. What next? I went from 2x minus 2 equals 5x to negative 2 equals 3x. What's that one? I did this, didn't I? Okay. Which instead of showing that, I just justify it by saying, yeah, I use subtraction property. Because subtracted 2x from each side. And finally, what are we going to do to both sides? Come on, you all can see what are we doing from two sides. Negative 2 equals 3x to x, negative 2/3 equals x. What am I doing to both sides? You all see it? Just say it out loud. You are? Division. Right? Yes? I've got like 3 or 4 people who are answering questions here, but I need to know the rest of you know this too. We're dividing, so we're using division property. And that is it. That's it. That's proof. That's justifying everything that we're doing, step by step by step. Let's do another one. I thought we were doing another one. Try again. A little shorter one, only 3 steps this time. Started with 3x minus 2 equals 8, that's given. The next step was 3x equals 10. What did we do to both sides? Added. So which property? Addition property. Yay. And finally, what did I do? We all see it. What is it? Division property. Okay. Now, people always say, do I have to write out the whole addition property of equality? No. I'm not that picky. Okay? I'll let you shorten and abbreviate as you think is appropriate, so long as you're getting the point across. But don't just say addition, you need to say addition property. So maybe you'd write add prop. That'd be fine. Okay? Because I know we're all basically lazy. We don't write out a whole sentence if I can write out 2 little short abbreviations. I do have to be a little careful, though. Excuse me. Subtraction property and substitution property will both be sub-prop. So substitution I usually do SUBST for abbreviation. And subtraction usually I say the whole word. And prop for property, which is fine. I can just leave off the of equality. I'm not going to worry about that at all. All right? So we can simplify that. I tend not to use the symbols because, and if we don't make our division sign really clear, it might look like an addition sign or vice versa. So it's easier to actually use the letters than the symbol. Also, that could be div prop. That would be fine. Okay? And we don't want to use just the x for multiplication because really, we're not in 7th grade anymore. We don't use x for multiplication anymore. X is a variable, not a symbol. Not often, at least. All right, let's do another one. So this time we have to work our way through. Now, this one's important because there's not just one way to do this. I have a lot of choices as to my first step. My first reason, of course, is what? What my first reason always is? Given. But step 2, I could do a lot of different things here. I could add 7 to both sides using the addition property. I could subtract 11 from both sides using the subtraction property. I could subtract the 1/3 x from both sides using subtraction property. I could add 2x or subtract 2x from both sides using subtraction property. I could even multiply the entire equation through by 3 and eliminate the fraction, couldn't I? Using multiplication property. Any one of those 5 would be correct. Okay? That's just lunch getting out. So one thing you're going to learn about proof is often there's more than one correct answer. There's multiple paths to get there. And it's kind of like me saying, how are you going to get from my room to Mr. Churchwell's room over on the English hallway? There's a lot of different routes we could get there. One is not necessarily better than the other. There might be a shortest one, but we get all these different routes. That happens sometimes in these proofs, and that's what we have. So what would you like to do? I'll give you the choice. What do you want the first step to be? Sammy's all excited to talk today. What do you want to do first? Add 7. Add the 7 to both sides. Fantastic. So, see what I did there? I used the fantastic. You see what I did there? And which property is that?
Addition.
Addition property. Okay. Kind of, yeah. But we're justifying why. We're not just solving the equation. We're as much about this as this right now. In fact, we're probably more about the reasons than the steps. Because that's the process that we're trying to learn in geometry is justification, the deductive reasoning, and justifying the steps. What would you like to do next? What do you want? Subtract 1/3 x from each side, okay. Now that gets a little bit messy, but it's certainly acceptable, because 2 minus 1/3 is just 5/3. And that was subtraction property. Now what? We don't need a common denominator. I could do several different things, couldn't I? I could multiply right through by 3 to eliminate the fraction, right? Or I could just divide both sides by 5/3, because if I just had 5x equals 18, I'd just divide by 5, right? So I have 5/3 x equals 18. I could just divide both sides by 5/3. And again, this is one is not right, one is not wrong. It's just what you prefer to do. Let's do it in 2 steps instead of 1 step. Let's multiply by 3 first. So 5x equals 54. What do I do to both sides? What is it? Come on, everybody. Multiplication. And then x equals 54/5, which is not a nice number, but who really cares, because it just came in at the very end anyway. We don't have to work with it. It's just the answer. But, or the solution, the answer is the whole thing here. Which property? All together, everyone said division. Division is off in our last step. There we go. Let's do another one. Looks very difficult, but it's not. Reason 1 is, of course, given. What would my first rewrite be? Oh, I've got these. Okay, I'll let you take a shot at this, because you two have been answering all day. Excellent. Which property did you use? Exactly. Yes. Distributive property. There we go. Nicely done. And you even remember to distribute the -5, not the +5. That's good, very good. What are we going to do next? There are better choices and worse choices, but there's plenty of good ones. Okay, so that would leave me what?
2 minus minus 2x.
Okay. And we combine like terms, so what do we use for that? What is it? Either one of you. Substitution. Thank you. We're going to have to do it again, aren't we? So -2x minus 13 equals 1. And again, it's substitution. Now, I could have technically just gone from step 2 to step 4. I didn't need to do that in 2 separate steps, because it's the same reason being used twice in a row. And I could have combined that into 1 step if I wanted to. It is not wrong to do it as 2 steps, though. Either way works. All right, what do you got next, honey?
Okay, use the addition property, add 13
So maybe I'll even write my reason first. So I get negative 2x equals 14. And which property are we going to use at the last step? Division, once again. And I get x equals negative 7. Again, why are we doing this? We need to explain deductive reasoning. We need to be able to explain why we do what we do. We're using something you know how to do well, algebra equation solving, in order to show you that process. So we're just using this to show you how that's done. Your homework is going to involve several problems like this. The first set from the homework tonight geometry, there we go. The first set, 6 through 20, are all equations that need to be solved. I want to see them in that 2-column format. Okay? 21 through 25 are just little fill-in-the-blank things. You can do those. Those won't take long. It's just kind of using the logic. Tomorrow we'll be busy with a review, a benchmark, and then actually moving right on to the next unit already. About 10 minutes of review time, 10 minutes for the benchmark. It does not take long. It is very short, 10 questions. And then on to our new unit. And notice we'll be starting right back at Chapter 1, Section 1. And you're going to have quite a few note cards from this one. In fact, some of them are going to involve pictures. And if you're not quite sure how to do them, at least get the words written on the front. For the homework check, if you at least have these words written on the front of your note cards, if you don't have your backs filled out yet, it'd be nice if you tried. But if you're not sure, leave it blank. We'll go over it in class, and we'll make sure you get them filled in correctly. All right? So I don't want you to have to redo them. But at least try. See what you can find. Okay? And we still have... This is PLC day. We still have 10 minutes, so you got lots of work time to get going on this. So let's get to work on it.